All right, so we're trying to prove what I've got circled there, given this other information. So let's start with the other information. A over B is bigger than or equal to C over A. Well, an obvious step is to cross multiply and get A squared is bigger than or equal to BC. Now, how can you be sure that's going to work? Well, they have told us that A is bigger than 1, B is bigger than 1, and C is bigger than 1. So it's not like you're multiplying by negatives. So that should work out just fine. That means if we take the log of both sides, log of A squared is bigger than or equal to log of BC, simply because they're positive numbers, the BC and the A squared. So if A squared was bigger than and or equal to BC, so is log of A squared. That means we end up with 2 log of A is bigger than or equal to log of BC. And so log of A is bigger than or equal to log of BC all over 2. Now, we come to a position where we need to deal with that situation there. Now, I know that there's a log rule that says if you're timesing, like log of a product, you can separate them out and make them additions. So maybe log A is bigger than or equal to log B plus log C on 2 might be a helpful way to have this written. And it is because we know the following. I'll just write it in green just here. Hey, that's supposed to be green just here, right? You know, because x minus y squared is bigger than or equal to 0, so we've got x squared minus 2xy plus y squared is bigger than or equal to 0, so x squared plus y squared is bigger than or equal to 2xy, and therefore x squared plus y squared on 2 is bigger than or equal to xy. And if we let x be a root x and y be root y, then root x squared plus root y squared on 2 root x root y, so x plus y on 2 root of xy. So there's a rule that we can use. Now in that rule, right, so we know that that's the case there, right? So I'm going to say, I'm going to call that equation 1. In equation 1, let x go to log of b and y go to log of c. We're going to transform in equation 1. So then what do I get? I've got log of a here, and we've got this is log of b plus log of c. Sorry, I probably should have written what I'm doing there, so I'm just going to get back and go in green. So log of b plus log of c on 2 is bigger than or equal to the square root of log of b times log of c. All right, now that's an important step because we need to somehow get from an addition of logs to a multiplication of logs, and there it is there. Now, because that's bigger than that, I can then say, therefore, log of a is bigger than or equal to the square root of log of b times log of c. Now, if I square both sides, I get log of a is being squared is bigger than or equal to log of b times log of c. That means that log of a times log of a is bigger than or equal to log of b times log of c. And I can rearrange this as is appropriate. What were we trying to prove? Let's just have a look. Trying to prove log a on log b equals log c on log a. So we can just do the dividing now, log A on log B, log C on log A. Okay, now just a word about your approach to this. Like, there was a key step in there which is written in green in the middle, which you needed to come up with, really. Now, some people work backwards. You know, some people they start with the final thing, log A on log B, bigger than or equal to log C on log A. So they go, that'll be log A, bigger than or equal to log B, log C. And so they go, all right, we've got log of A squared bigger than or equal to log of B times log of C. Now, there's a problem in getting any further from here, because it's not log of A squared, it's log of A times log of A, right? So that's actually log of 2A if you're going to try to put it together. But otherwise it's log of A squared. So we end up with log of A being bigger than the square root of log of B and times log of C as another way of representing that. But we run into a problem with trying to get the summation that's required. Because if you're trying to run backwards to see which way you should run forwards, you know, you end up there and go, well, now what can I do? But if I was able to turn this into log B plus log C, then it'd be log of BC, which is what I'm requiring. So I need to have this step up here. So sometimes working backwards gets you a way to go, and sometimes it gets you stuck in the middle, but you can see what inequality you might need to use to get past that point for those people that work backwards from the answer. But I think it was pretty clear that you should start off with the given thing and work it through like I have until you reach this, and then say, well, what I really need is a multiplication and not an addition there. And so you need to use an inequality to get that.